Now? Can you hear me now, guys? Yeah, now? Hello, hello, hello. Hello there. Testing, testing. Yes, okay, now we can hear you. Okay, okay, excellent. Great. Okay, so I have been talking a lot and you haven't heard anything. Okay, excellent. So sorry for this because, as I've said, we've been doing some changes here and we had to do the setup from zero almost. So some things there. Okay, but now the sound is fine. Excellent. So let's go for it. Let's go for it. Then, well, basically what I was saying is that today we are at live class number 96, so only 4 left for the 100th live class, which is amazing, let me say. And today we are going to be doing the live class about some OpenCV basic concepts. Specifically, we are going to talk about face detection. We are going to be using the HaarCascades method. We are going to see it in a moment. So yeah, let's go for it. Then, as always, I'm going to share with you the project. Let me do that right now. But before anything else, let me get here my energy drink from my super fancy ROS developers Mac. Which, by the way, we were giving away some of these Macs and also shirts in the ROS Developers Day. So maybe some of you already have this Mac as well there with you. I don't know. If you won one of the quizzes, then you might have this Mac as well as the shirt, as the ROS Developers shirt. So let's go for it. Let me change real quick the screen to my ROS Developers screen. Here I have it, and as always I'm going to come here, copy link, and I'm going to share this link with you guys here in the chat. There we go. Alright, excellent. So once you get this link, as always, click on the link. You are going to get this project, this one here, the one for the live class number 96, into your workspace. If you don't have a ROS Development Studio account, just create it. It's free and it's going to take you some seconds only. Then once you are logged in, you are going to have this project here. Then in order to open it, just click on the open button and open project. Yes, and this is going to start opening here the project. And let me open this. Meanwhile, my project loads. This is going to take maybe 1 minute to load the whole environment. So just be a little bit patient. Then, all right. So meanwhile this loads, let me switch here real quick to my face again, and let me know if you get the project without problems here, and let me know as well how many of you were in the ROS Developers Day, which it was last week, I believe, in Saturday. Were you attending the event? Because we've been a couple of weeks, 2 or 3 weeks, I think, without live classes because of this event, because we were preparing the event, and during this week we are going to be publishing all the different speeches of that conference. It was amazing. So let me know if you were there, if you were in the ROS Developers Day 2020 conference. Meanwhile, I can see here, yes. Hello everyone, says Shahudullah Khan. Hello Shahudullah. I don't know if your name is spelled like that. Probably not. So sorry in advance. All right. So let me check here. Hello, says Ali Aidin, and I'm not going to go for that surname. It's too much for me. So guys, how it is going? Are you all opening your project? Yes? Have you got the project and are you opening it? Hello. Aaron John, Bishal, Jerry Zhao, there also Kor Hong Ki. which is asking, any first timer here? Hello, are you a first timer, core, honk? 5 days of ROS was amazing, says Hash. Yeah, that was that was already some months ago, I think, when we did the ROS Basics Week, I think it was called, right? More or less, yeah, the beginnings of the quarantine and everything, we did this, and it was amazing, honestly. Many people was attending those streams. Still loading. Okay, so I can see all of you more or less are loading your projects, guys. Let me share again my screen here. So at the end, you are going to have something like this. When your project finishes loading, you are going to have something like this. Yes, you are going to have here your environment opened, loaded, and here you are going to have automatically opened this Jupyter notebook, which basically contains everything we are going to do during today's live class. Yeah? So yeah, I'm going to wait for you guys to have this project open. Let me know in the chat if it's still loading, if you have already loaded your project as mine, if you have it as mine here. Loaded, says Asif. Okay, great. First timer. I can see there are some first timers around here, so welcome everybody. Will 5 days ROS will happen again? I don't know. Maybe we have to. So now in the short term, it's not planned to have another 5 days, another ROS training week. Let's say it is not planned for now. But who knows? So maybe in the future we decide to do another one. So just stay tuned for the news. Hello everyone. Hello Kamar. So how it is going, guys? Have you opened your project? Want to apply depth using OpenCV to robotics. What do you mean by apply depth? Sidhu Burat is saying that. I don't know what do you mean by depth. Want to apply depth. Yes, Kamar. So I suppose you have already your project loaded. Yeah, that's true. Yes, no. It's loaded now. Open it now. Okay, excellent. So I see that people is starting to get their projects opened. So I'm going to start slow so that everybody can catch up. But I'm going to start. Then you should have this notebook as I have for ROS Developers Live Class number 96. Then a couple of requirements for this course. So one of them is to have some basic concepts of Linux as well as some basic concepts of Python. Then you can get both of them by doing our free courses. So we have here in our academy, if you come here to the courses section, you're going to come to our academy where we have all our ROS related courses. Yes, many of them. We have courses for Jetson Nano, for instance, deep learning, autonomous vehicles, using OpenAI with ROS, deep learning, ROS basics as well in Python and C++. Also courses for ROS 2, as you can see. Many different courses. You can have a look. And we have also these two free courses, which are the Python 3 for robotics and Linux for robotics. Then you can have a look at them. You can complete them completely for free. They are free. So you can have a look at them and you are going to get some very important knowledge about Linux concepts and Python concepts, yes, which you are going to need. So if you want to work with ROS, you are going to need to have this knowledge on Linux and Python. Yeah, super important. So have a look to these two free courses. Then next thing, so let's set up the environment. So we are going to be working with a simulation, with a drone simulation in this case. And in order to start it, all we have to do is to come here to the simulations button here in the top menu, click on the Choose Launch File button, this blue button that appears here, and from here we are going to be able to select from different launch files. In this case, we are going to select this one, the course simulation 3.launch from the Unit 3 sim package. Yes? So I'm going to select this launch file and click on the launch button. And this is going to automatically open and start loading a gazebo simulation. Then when this simulation finishes loading, we are going to have something similar to this. Yes, with this drone, a person standing here in this kind of forest, this house in a forest. Yeah. So let's wait a couple of seconds until my simulation finishes loading. There it is starting to load. Let me make this a little bit bigger, adjust it here. There we go. Alright, so this is finishing loading yet. It has loaded the drone. There we go. So here I have it. Yes, then here I have my simulation loaded here with this drone, this Hector Quadrotor drone, which is in front of this person, and all this is in this kind of forest environment. Super cool. Yeah, but you should have this. Then at this point, we are prepared and set up to start with the live class. Yes, so now I want all of you to be in the same point as I am. So you should have your gazebo simulation loaded here, and also the project, the notebook, the Jupyter notebook opened here. Yes, because here in the notebook is where we are going to be following all the instructions and all the exercises and everything we are going to be doing. We have everything here explained in the notebook, and then we are going to apply later this into the gazebo simulation and into this environment. Yes, into this drone with this person. Yeah, so I want you guys to have this setup. Yes, and this is super important, and it's super important because I don't want you to just sit there in your houses in front of your computers and listening to me, listening to what this crazy guy is saying. No, I don't want you to do that. I want you to practice with me. So meanwhile, I'm going to be here explaining things and doing all the examples and all the practice. I want you to be practicing with me at the same time. Yes, this is why I have shared this project with you, so that you can open it and you can reproduce everything that I do yourselves. Yes, this is how you are going to really learn. Then let's go back to work. So guys, let me know now in the chat if you are set up, if you are at the same point as I am, so that we can start with the live class. Matthews Chediak asks, why don't you guys make the tutorial using real Linux OS instead of web-based ROS? That is a super good question. So why don't you guys make the tutorial using real Linux OS instead of web-based ROS? So why we are doing in this platform, which is called ROSDS, which is web-based, why we are doing it here? Well, because this way, anybody who wants can reproduce exactly the same as I am doing. Yes? So I have created this project here, this ROS project, which by the way, it's based in Linux. Yes? So this actually is a computer which runs Ubuntu 16.04 with ROS Kinetic and Gazebo 7. So actually, all this is running under Linux. But it's web-based. In fact, it's cloud-based. So all of this is running in the cloud. And why we do it like this? Because this way I can create this project and I can share it with all of you. And once I share it with you with the link, as I have done at the beginning of the class, once you click on that link, you are going to get exactly the same project as I have with the exact same environment that I have. Yeah, so you are going to be able to reproduce exactly everything that I'm going to do here. And it doesn't matter anything. It doesn't matter if you have a Linux computer, It doesn't matter if you have a Windows computer. It doesn't matter if you have a Mac, for instance. Anybody with a web browser is going to be able to get this project and reproduce it. Yes? So this is super powerful, guys. Even anybody can attend this live class and follow it and reproduce it. Not just listen to me, but they are going to get this project and they are going to be able to reproduce it in, for instance, a Windows machine or a Mac machine. Yes? If I did this in a Linux machine, in a Linux OS, I could do this, but this would be prepared for my environment. Maybe you have a different version of Linux and then it doesn't work for you. Maybe you have Windows or Mac, then you directly cannot install ROS, so you cannot follow it. Yes? So this way anybody can follow this live class and reproduce everything that I do. So that's why we are doing it here. Setup ready. All right, so let's go for it, guys. Let's go for it. Then I'm going to start with the live class. So face detection. Yeah. So basically, in this live class, we are going to talk about the HaarCascades method, which is a classifier. It's an object classifier based on machine learning. Yes, specifically it uses AdaBoost, which is a very popular algorithm for machine learning. Yeah. Then why do we need to detect faces? Or why do we need to detect people? Why I'm doing this live class? So why do I want this? Well, this is super important in robotics. Yes, in robotics and in artificial vision, in fact. Yes, because robots are meant, well, at least in my opinion, robots are meant to interact with people. At least this is what I want. In the future, I want robots that are able to interact with people, that are able to help people to do tasks, that are, basically, my idea of robotics for the future is to be able to create robots that actually are able to help in some meaningful way to humans, to us humans. Yes? Then for this, we need robots to be able to detect humans, first of all. Yes? We need them to detect faces, to recognize different faces, for instance, or detect people in general, and also be able to track people, etc. Yes? So this is in my opinion, this is a very important field in robotics. Yes? People detection, face detection, people tracking, etc. Yes? However, as I said, HaarCascades, it is a classifier. What does this mean? Well, this means that despite we are going to use this method for face detection, this doesn't mean that it cannot be used for any other tasks. Yes, we are going to use it for face detection, but it could be used for almost anything we want, depending on what we train this classifier for. Yes? Then basically how this works, the idea under this algorithm is to extract important features from an image that describe something we want. Yes? So given an image, we extract important features from that image, and these features are something which can help us detect that object as something in particular. So for instance, as a car. Yes? So basically we are going to extract these features and we are going to use these features to train the algorithm using machine learning so that it can generalize the abstraction of this desired object. Yes? So summarizing, the process is that basically we extract characteristic features of an image and then we train on these features so that our algorithm can detect the same object in other images. Yes? Make sense? So let me have a quick look at the chat to verify that everything is going properly. All right, so let's keep going. All right, so yeah, in the computer vision world, one of the most important tasks, as I've said, in my opinion, is classification of objects in general. Yes, because this can be used to detect faces, but this can be also used to detect a car, for instance, to detect mugs in an image, to detect any object. Yes, it depends on how we train our algorithm. Yeah. Then, for instance, this is used actually in some social apps like Snapchat, where there are algorithms that detect your face. Yes, nowadays in many, even in many smartphones, if you have smartphones with the regular camera, there is even some of them that already detect where your face is. Yes, so this is super extended nowadays. Then we are going to use, in this case, the HaarCascades. Yes, so this was proposed by Viola and Jones. I have linked it here. If you click here, you are going to go directly to the paper. Just in case if you are interested in reading the paper, you can download it here to go more into the detail. Yes. Whoopa. But basically, as I've said, how this works is to detect features of an image. Yes. Then detection of objects with this HaarCascades method works in two stages. Yes, the first one extracts important features from the image, and the second one uses an algorithm to classify this information. Yes. So basically, as we can see here in these GIFs, let me find another one. Yes, this would be the characteristic feature of the image, and then we are going to test this feature. We are going to compare this feature on all the different areas of pixels of the image. Yes, as you can see here. However, this would be this would consume a lot of resources, right? If we have to test every feature for every pixel of the image, this would be just too much. Yes. Then an interesting thing to note here is that this comparison between the features and the image, it has different stages, let's say. Yes, so there are different features. We have more general features and we have more concrete features. Yes, then we are going to start testing these general features all around the image. Yes, so for instance, let's say that we have this image here, or let me look here for an image in the notebook. It would be better. Yes, let's come here. Yes, so let's say that we have this image. Yes, then we are going to start with the general features all around the image. Yes, then these general features are going to do a first filter in order to determine if we are in a region where there could be a face or not. Yes, if there is not going to be a face there, then that region is automatically discarded. So we are not going to do any other test. We are not going to test any other feature into that region. Yes? So in this case, we would start testing all this region, and then all the regions where the first characteristic features don't detect a possible face would be discarded. Yes? Then on the regions where there could be a face, which would be this region here, then we would keep testing there other characteristic features. Then if the second characteristic feature fails, then it's going to be discarded. But if it passes, we are going to test yet another feature and another feature. Then if all the features pass, are positive, then that region is going to be a face, of course. Yes? Does it make sense, more or less? Okay, anyways, I don't want to enter into too much detail here, because for that we already have the OpenCV course for robotics, where you can go into more detail of how this HaarCascades classifier works. And also I don't want this class to be too much theoretical, but I want to do some practice and see the results of this. Yeah, so yeah. here we have then an example of code in Python of how we would use this HaarCascades method in order to detect a phase. Yes, here you have the code example, and this is the result. Yes, so given an image, we would have a detection like this, marked with a rectangular box, of the region where the algorithm has detected that there is a phase. Yes, and this can work, of course, with a single phase or with multiple phases, as we have in this other image. Yes? Then, let's analyze more or less the code and what is going on here. Yes? So first of all, as always, we do some imports of modules, libraries that we are going to use. In this case, we are importing NumPy and CV2, which is basically OpenCV. Yes? Then here what we are doing is to upload the classifier. Yes, in this case for the frontal face XML. We are going to see later this phase, but basically this phase is the this XML file. Sorry, this XML file is the already trained file which defines the characteristic features of a face. Yes. In this XML file, we have all the characteristic features of the face. Yes? Then we are loading the cascade classifier with this file, which is already trained for us. Yes? Then also, what else? What else we are doing here? We are reading two images. We are reading these two images. This image with the single face and this image with the multiple faces. You can see them here. We are reading them with the emRead function. And we are resizing these images. Yes? In this case, in order to make them a little bit smaller, so that we can reduce the computational resources of the machine. Yeah? What else? Then we convert them to grayscale. Yes, we do this for both images, for the face image and for the many image. Yeah, so we do this for both images. Then we set the scale factor to 1.2. This scale factor determines how much the original image is going to be reduced in every scale. Then we are going to determine the number of neighbors to a higher value, so that the model will be more selective or less selective. Yes, in terms of detecting a phase. Yeah, we can customize this here with this parameter, the mean neighbors, in order to make it more or less selective. Then we are applying the HaarCascades method to the grayscaled images. Yes, remember that here converted the images to grayscale, and then here we are applying the HaarCascades method to these images. Yes? Then once the algorithm finishes analyzing these images, so analyzes these images and tests all the features into these images, then we are going to extract the coordinates of the detections. Yes? So the algorithm is going to provide to me the coordinates, the region of the image where he thinks there is a phase. Yes? Then we are going to extract these coordinates. Yes? Here with this force that we have here. And then finally, with these coordinates, what we are going to do here is to draw a rectangle in that area. Yes? In this case, as you can see from this image here, sorry, it's down here. Yes? So here in this image, we can see this rectangle which has been printed here in the area where the face is. Yes? So we are doing this basically here. Yes, calling this rectangle function from CV2. Here we have it. And we do the same then for the second image. We paint a rectangle, etc. And then finally we show these results in a graphical GUI. Yes, we show both results, the face and faces, using the show function. Yes? Alright, so this is, however, too much theoretical, right? So I have explained it a little bit here. The code, more or less, it makes. Let's test it. So let's do an exercise with this. So this is what we are going to do right now. Let's see this in action. Yes? So let's start. Let's start with practice, guys. Okay, so first of all, we are going to open a web shell here. Yes? This is a regular Linux shell. So the first thing we are going to do is to come here to the Catkin workspace, src folder. Yes? Next, we are going to use the Catkin create package command in order to create a new ROS package. There we go. In this case, we are going to name this package live class 96, and we set ROSPy as a dependency for this package as well. Then let me execute this command here, and this basically is going to create a package. So let me open the IDE so that I can visualize here graphically my files and my workspaces and everything that I'm going to be doing. Let me open it right here. Let me reorganize this a little bit. Here my IDE is loading. Let me try to refresh it here. Sometimes it takes some seconds. There we go. Excellent. So here I have all the workspaces. Then in this case, I'm going to be working with the Catkin workspace. So let me open this. Then inside the src folder here, I have my package, which has been created live class 96. Yes, you are going to see also another folder here, which is this live class images, which I have already placed here for you, because we are going to use it now. Yes, but this one has already been created by me. Yes, you are going to also have this folder here. Then next, inside this package, create a new folder and call it HaarCascades, and create two files named frontalface.xml and iXML. Okay, so in my package, in my live class 96 package, I'm going to create a new folder. I'm going to name it HaarCascades. There we go. Now into this folder, what I need to paste are these two files, frontalface and iXML. So for this, what I'm going to do is to copy them from this live class images folder, because here, as you can see, I already have this folder with these two files. So what I'm going to do is to copy them directly to my package. So let me open another shell in order to do so. cd Catkin workspace src live class images and HaarCascades. So here I have the two files, iXML and frontalface XML. So I'm going to copy both of them and move them to my package, which is live class 96 HaarCascades. There we go. So now I have these two files here inside the HaarCascades folder of my package. There I have them. So as I've said before, these two files, the frontalface XML contains all the characteristic features for detecting a face, and the iXML contains all the characteristic features to detect the eyes. Yes? So we are going to detect not only the face, but also the area where there are eyes. Yes? We are going to see it in a moment. Alright, so let's keep going. What else? Then, okay, inside the src folder, create a new file and call it recogniteface.py. Okay, so inside this folder, which is named src, I'm going to create here a new file and call it recognizeface.py. Yes? Then, there I have it. Then, into this file, what I'm going to do is to copy the code I have here. Yes? So let me, well, in fact, let me come, because this is the first version of the code, and here I have the final version of the code. So I'm going to copy this one. Yes, the second one, which is under this show the result and the original image. Yes, this is the final version of the code. So I'm going to come to this second code here and copy all this code. Yes, so let me come here and just copy it. There we go. Let me select everything. Control C and Control V. I'm going to paste it here to my file. All right. Then there I have it. So let's have a look at this code now. What are we doing here? Most of it is what we have already explained. Yes. So in this case here, it's everything is located into a Python class. Yes. So we have this Python class with the constructor. And in this constructor, in this case here, we are subscribing to the camera. However, this we are going to analyze it better later because now we are not going to use it. So let's just focus on this section of the code here. Then basically what we are doing here is to load the two cascade classifiers. Yes, the frontal face XML and the eye XML. Yes, the two we have here, we have placed it inside the HaarCascades folder. Eye and frontal, we are loading them, we are loading these classifiers, yes? Then what else we are doing? We are reading a file here, we are reading an image, we are getting an image, which is here, inside the live class images folder. So here you can see that we have an image. Let me come here and download it, so that I can visualize this image, yes? So basically here, I am loading this chris.jpg folder image, which I'm going to show you right now. It's this image, yes? So I am loading this image into my algorithm because I'm going to analyze now this image. By the way, this image is from Chris, which is the main teacher of the OpenCV course, yes, which has also provided the contents for this live class, and he has created our OpenCV for Robotics course. So you can see here his pretty face. As you can see, he's very handsome. He's single also, I think. So guys, if you are interested, just let me know. No, just joking, sorry. I'm just joking now. So, all right. So, okay, so I am loading this image into the system, yes? Then what I am doing here basically is to resize this image. Yes, I am making this image a little bit smaller so that I can reduce the computational resources. Yes. Then here, as we can see, we are converting it to grayscale. We are also applying the scale factor and the mean neighbors values, which we have explained right before. Then we are applying here the cascade algorithm to this image. Yes, here is where we are applying the algorithm, and then once we have the coordinates, we are going to use these coordinates in order to write a rectangle both for the face and for the eyes. Yes, so we are going to write a rectangle here for the detection of the face and another rectangle here for the detection of the eyes. Yes, so here we are detecting the face and here we are detecting the eyes. Yes, and then finally we are going to call this IMShow function from CV in order to show the results. Yes? Alright, so let's test. Let's test if this actually works. So let me come here super fast. Then one thing I'm going to need to do is to make sure that my Python script has execution permissions. So let me do this super fast now. Let me check here my Python file, which I have here, recognize face. Okay, it doesn't have execution permissions. So for this, I'm going to execute the following command. Recognize face.py. There we go. Now, as you will see, the file is going to turn to green color, which means that now it has execution permissions. So now that I have done this, I am able to run it. So let me run it. Then ROS run live class 96 and recognize face.py. So let me run this command here. And now, in order to visualize the results, what I'm going to do is to open the graphical tools. So I'm going to come here to the graphical tools. I'm going to move this to a different tab here because I already have too many things here. Yes. And now here I can see the results. Yes. So here I have the original image. Let me move it here. Here I have the original image. And here I have the image after the detection and after I have printed these rectangles to the face area and to the eyes area. Yes? So pretty good and accurate results, right? All right, then let me stop my program now. So what do you say, guys? Have you been able to get these results as well? Have you been able to detect here? Let me move it here. Have you been able to get the result as well? To detect here the face and the eyes? Let me have a quick look at the chat. Okay, I can see there are some problems here. What problems? With the stream, you mean? There are problems with the stream? I can see, yeah. Guys, on my machine, the live stops for a couple of seconds all the time. Do you have this problem? Okay, so we have these internet problems again. Damn, this is really a shit. Can you follow me now, guys? Can you hear me at least? Let me know, guys, in the YouTube chat so that I can get some feedback here. Okay, yeah, I think there might be some problems. Well, I'm going to try to finish the stream the best I can, the live class, sorry, the best I can. And, well, yeah, as my colleagues have said, we are going to take action for next live class because this cannot happen again. It's not acceptable. So yeah, this it has to have a proper quality. I mean, all right. Anyways, let me just keep going and finish with the live class as best as I can. All right. So then let me come here and close this. Let me check. All right. So yeah. Okay. Then this is super nice. However, here we have a simulation which we haven't used until now. Yes? So now what we are going to try is to, instead of detecting an image, of detecting a face from an image, from a real image, we are going to try to do this in the simulation. Yes? Okay, so let's go for it. Then inside the package you created previously, create two new files and call them flyingdrone3.py and recognize face sim.py. Okay, so let me create these new files here. flying drone 3.py and recognize face sim.py. There we go, recognize face sim.py. There we go. Then inside the flying drone script, we are going to paste this code here. So let's do this. Let me copy and paste this code I have here. There we go. And paste this into the flying drone script. And for the recognize face, we are going to copy and paste this code we have here. Let's go. Alright, then let's have a super quick look. Well, no, we have still one more step, which is to create the launch file, so I'm going to do it right now. Then let me copy this code here for the launch file directly and create the launch file as well. So I'm going to, first of all, inside my package, create here the launch folder, new folder, named launch. And let me open this. And here I'm going to create the new launch file named recognize face sim.launch. And here I'm going to paste the final code. So there we go. Alright, excellent. So now let me just very quickly analyze these new scripts that we have created, which are two. So we have this flying drone script, which basically is a ROS script. You can have a look yourself here. This is just pure ROS, which is going to make the drone take off and start moving up until it reaches a distance, more or less, where it can properly detect the face. Because here, as we can see, the drone is more or less looking at the feet of the person, yes? So with this script, what we are going to do is to make it move up until the height, more or less, of the face, so that it can properly detect the face of this person that we have here, yes? So basically this flying drone script, it's what it's going to do is to make the drone fly up to the height of the face of the person, yes? And then we have as well here this recognize face sim script. So here what we are doing now, yes, what we are doing is to, first of all, we create a ROS subscriber, which is going to subscribe to this topic, camera/RGB/image raw. Then this topic is the topic where the drone is publishing the images which is capturing with his camera, yes? So this drone has a camera, yes, mounted, and this camera obviously it's capturing images, yes? Then all these images that the camera is capturing are being published into this topic, camera RGB image raw. Then what I'm doing here is to subscribe to this topic. Then also I am creating here a CV bridge element, yes, which is going to allow me to connect the OpenCV libraries with ROS and use them within ROS, yes? This is basically the main use of CV bridge, yes? Then basically what I'm doing here, first of all, this is the camera callback, yes? So this is the callback for this subscriber. As you can see, we have set it here, camera callback. Then each time a new image is published into this topic, this camera callback function is triggered and is executed. Then first of all, what I do is to convert the image from this topic. I'm converting it into a CV2 compatible format, yes? Because the image that I'm capturing directly from ROS, it's not directly compatible with OpenCV. So what I am doing here is to convert this image, the image that I'm getting from this topic, I'm converting it into a format which is compatible with CV2. Yes? Then, what else? I am loading here the classifiers for the face and for the eye. We already know this. I am resizing the image. I am converting it to grayscale. And I am applying here the algorithm for the face first. And here for the eyes. Yes? And then, in both cases, I am getting the coordinates of the detections and I am printing the rectangles for the face and for the eyes. Yes? And then, once both detections are successful, what I am doing here is to call the emWrite function. So I am taking a picture and I am saving it into this folder. So I am saving it into the package that I have created, LiveClass96, inside the SRC folder, this one. I'm going to save an image, which in my case I am naming like this, Eustaquio.jpg. Yes? So once the two detections are positive, I am going to take a picture of the image and I am going to save it into this folder. Yes? And finally as well, what I'm doing is to show the results, yes, of the images and the detections. So, all this being said, let's execute it. Let's see if all this works. So let me come here. And as before, what I am going to do, first of all, is to make sure that my Python files, my new Python scripts, are executable. So let me come here and verify this. They are not right now, so let me give them execution permissions to the recognize face sim and flying drone. There we go. Now both of them are executables, and now I am going to run everything with the launch file. So ROS launch LiveClass96, and I'm going to execute here my launch file, which is going to start the flying drone script and the recognize face in simulation script. So let me execute this, and now here in the simulation, what we are going to see is how the drone takes off and it starts flying up. Here we can see it. Yes, there we see how the drone. Let me stop this. Here we can see how the drone starts moving up. Yes, it's going super slow in this case, but it just starts to balancing and to going up. And here as well, we can see the camera feed. So here we can see what the drone is seeing right now. Yes? Then now, right now, it's just still balancing and going up. The drone, as we can see. We can see it here how it's going up. It's going slow, yes. So right now here we have a small instance, and this takes a lot of resources for running the algorithm. So this is running a little bit slow here in my machine, but don't worry, just we are going to be a little bit patient. Also, one thing we need to take into account. Okay, so here it's already, and we can see here how it has written a rectangle in the face. Yes, excellent. So as we can see, it is detecting the area in the simulation where there is a face. Yes, and this is